This is the fifth in a series of videos on computer building and modification, and focuses on the importance of graphics in modern computers. There are two main types of graphic processing units, GPUs. First of all, integrated graphics, which are built into the CPU and use shared system memory. And secondly, discrete graphics cards, which have their own dedicated memory and provide higher performance. We discuss the benefits and drawbacks of each type, along with considerations for choosing and installing a graphics card, such as PCIe slot compatibility and power supply requirements. Modern computers require at least one screen or monitor to output to. The processing of the video signals needed to drive these monitors are either integrated into the motherboard and CPU, or within a discrete graphics card. As we can see on this motherboard, there are sockets that can be used to connect to monitors. This motherboard and CPU has integrated graphics built into the processor in the form of an embedded GPU, or Graphics Processing Unit. Integrated graphics hardware doesn't use a separate memory bank for graphics and video. Instead, the GPU uses system memory that is shared with the CPU. Since integrated graphics are built into the processor, it typically uses less power, and as a result, produces less heat. Integrated graphics allows laptops to be much slimmer and more power efficient than they would be with a traditional discrete graphics card. For desktop systems, this can allow the motherboard to be much smaller. One of the most common upgrades on a desktop computer is the addition of a discrete graphics card. Discrete graphics cards have their own dedicated memory that is not shared with the CPU. Being separate from the processor chip, they usually require a dedicated power feed and can generate a significant amount of heat. Such graphics cards will have a fan or fans plus a significant heatsink to help dissipate the built-up heat that has been generated. However, they do have their own dedicated fast memory and provide higher performance than integrated graphics. A discrete graphics card can be considered to be a computer in its own right, as it has both a processor and memory. In both integrated and discrete graphics, the graphics processor is dedicated solely to graphics processing, which reduces the load on the CPU. So do you need a discrete graphics card? Well, it all depends on what you plan on using the computer for. If you're going to use the computer for checking your email, most of the social media platforms, and watching YouTube videos, then you're unlikely to require a discrete graphics card, as integrated graphics should cope with this without problem. Alternatively, if you plan on doing video editing, computer-aided design, or the very latest games, then perhaps you should consider the benefits of a graphics card. Integrated graphics have improved considerably over the last few years, and many older games that once would have required their own dedicated graphics card can now be played on a system with integrated graphics. So if you decide that you wish to upgrade your desktop computer by adding a graphics card, what do you need to do? The graphics card will plug into a slot on your motherboard. Motherboards often have one or more PCIe slots suitable for a graphics card. PCIe slots are designated by ×1, ×4, ×8 and ×16. This indicates the number of data lanes provided on that PCIe slot. The higher number, the more data lanes that are provided. ×16 is ideal for a discrete graphics card, as this will provide the highest bandwidth to the card, allowing data to flow to and from the graphics card faster. PCIe has gone through a number of generations, from PCIe 1 all the way up to PCIe version 6. Each generation has delivered faster data transfer speeds from the previous generation, so check your motherboard documentation to see which generation of PCIe it supports. If you are looking to purchase a new system by buying the parts and assembling it yourself, then you need to do some research on your CPU, motherboard, and GPU combination. Some CPUs do not support integrated graphics, even if the motherboard has monitor output sockets. Having decided on a suitable graphics card for your motherboard, the next consideration is the power supply. Graphics cards can require a significant amount of power, sometimes even more than the rest of your computer combined. As such, you need to ensure that the power supply you have, or intend to buy, can cope with the combined demands of the graphics card and the rest of the machine. Ideally, err on the side of caution, and equip your computer with a power supply that can supply more power than you estimate the computer will need. This extra capacity is a safety net to handle momentary spikes in power demand, and also builds in an element of future-proofing, allowing later additions to the computer to cope with increased demand. To arrive at the required power needs for your computer will involve you doing some research on the maximum power draw for each component and then adding on a little extra for contingency. Graphics cards come in a range of sizes, both length and width. You need to ensure that there is enough room in your computer case to accommodate your selected card. Is it too long or too wide? The most recent graphics cards can be described as 2 or even 3 slots wide. This refers to how wide the card is, and plugging it in will overlap 2 or more PCIe slots. Do you have room to accommodate the width of the card? The last physical aspect to consider is cooling. Graphics cards can produce a lot of heat, hence the cooling fans on the card. So if you're fitting the graphics card to an existing computer, you may have to rearrange or add more cooling fans to the case to ensure the computer does not overheat. Like many components in your computer, the graphics card requires drivers in order to interface with the rest of your computer and operating system. Many GPU manufacturers supply these drivers via an automatic update facility to save you having to check their websites yourself. While a majority of these updates relate to supporting new games that have been released, like all software, there will be bug fixes and feature enhancements too. Your graphics card really is a computer within your computer. There are many graphics cards being sold by many vendors. The key points to take into account are the amount of memory, the power requirements, the physical size of the graphics card, both in width and length, and finally, the cost, as the top-of-the-range cards can be seriously expensive. Hopefully this short coverage on both integrated and discrete graphics has been useful to you. But that's it for today. Thank you for watching.